Hello everyone. Today we're going to create a Codesys application that can communicate with a Compact Logix PLC and a Modbus RTU device. To do this, we're going to use Weintek's CMT2078X with built-in Codesys and the latest version of Weintek's IDE, EasyBuilder Pro. Now, Weintek's built-in Codesys can communicate with most devices using Modbus TCP, Ethernet IP, EtherCAT, or CAN Open. But Weintek's Codesys does not support certain specialized protocols or those that require a serial interface, like Modbus RTU. This is due to the architecture of our Codesys implementation, as the HMI retains control over all available serial ports after Codesys activation. And yet, this is actually beneficial. Weintek HMIs are well equipped to communicate with most PLCs, sensors, and I/O, and support over 400 communication protocols. So, allowing Codesys to control a serial port will detract from the HMI's ability to communicate using a non-standard protocol that requires a serial interface. But this architecture is beneficial because our HMIs can actually route requests from Codesys to an external device using almost any of the 400+ communication protocols within EasyBuilder Pro. Before we discuss this application in detail, I'd like to mention that Weintek now recommends Codesys IDE version 3.5.15.50. And, in addition to this installation, you may want to install the latest Codesys package and the required Modbus TCP device description files. All of these items and more can be acquired on our forum, forum.weintechusa.com. And if you're just starting out with Codesys, be sure to check out the New to Codesys topic within the Codesys category. With that said, during this demonstration, I'm going to follow the instructions within the post titled Weintek's Modbus Gateway. If you check the description below, you'll find a link that will take you to this post as well. To begin, you'll need to create an account on our forum so that you can download the recommended instance of Codesys, the latest Codesys package, and the Modbus device description files mentioned within this post. This instance of the Codesys IDE and these Modbus description files were validated by our QA team as compatible with our runtime. And there is a chance that using a different version may prevent the application from communicating with the target device. With that said, I already have the recommended instance of Codesys, and the Codesys package can be installed by right-clicking the package file and selecting Open with Codesys Package Manager. But the device description files are a little more complex. So let's review how to install the Modbus description files linked within this post. To begin, I'll download and extract each XML file. Then, within Codesys, I'll open the device repository. This menu can be found within the Tool tab. Once open, I'll click the Install button to add the required Modbus description. Now, let's talk a little bit about the concept that we're going to employ. I mentioned that the HMI is going to route requests from Codesys to an external device. Well, in order to do this, we need to use Weintek's built-in Modbus TCP/IP gateway. This feature allows the HMI to function as a Modbus server and associate Modbus registers with registers or tags in an external device, like a Compact Logix. The process of building this association is called mapping. When a Modbus master, in this case Codesys, sends a request targeting a Modbus register within the server, this request is relayed by the HMI to the memory allocation within the external device that is mapped to this register. As an example, Codesys can be made to write to register 4x1 within the HMI. The HMI can then relay this request to a tag within the Compact Logix that was mapped to this register. And before I introduce any more Modbus registers, I'll quickly note that 4x registers are used for analog output, so they may be read from or written to. 3x registers are used for analog input, so they are read-only. 0x registers are used for coils or digital outputs, so they may be read from or written to as well. And 1x registers are used for contacts or digital inputs, so they are read-only. Let's open an instance of EasyBuilder Pro and define our Modbus mapping. With EasyBuilder Pro open, I'm going to create a new project for a CMT2078X. But please select the HMI model that you are using within this application. While the application loads, a menu called the System Parameters will display. If you are working within an existing project, the System Parameters can be found within the Home tab. Within this menu, select the New Device/Server button to add a new communication driver. Within the following menu, click on the center of the drop-down list to search for a driver. In this example, I'm going to add the Rockwell Ethernet IP Compact Logix Free Tag Names driver. I'll configure the device IP and click OK to add this to our device list. While this driver is selected, I'm going to click the Import Tags button to import our L5X file. And when finished, I'll click the New Device/Server button once more to add our Modbus RTU driver. Once the parameters are configured, I'll click OK to add this driver to our device list. As is, the HMI is not yet a Modbus server. In order to make the HMI function as a Modbus server, we'll need to add a Modbus server driver as well. We can do this using the same method that we used to add the Modbus RTU driver. Within the configuration menu for the Modbus server, let's enable Modbus TCP/IP gateway. And then we'll click the Address Mapping Tables button to define our Modbus mapping. Now, by default, there will be some tables that are already defined, but you'll notice that these are all mapped to addresses within the HMI's internal memory, which we don't yet know if we'll use. So for now, we can just delete these tables. Then, we'll use the Add button to add a new table. And before I adjust any of these settings, let's quickly discuss the options within this menu. At the top, we can add a comment to describe this table's purpose. The comment will also display within the table list. We can set the address mode to either bit or word, which will change the address types available within the Modbus and map device address drop-down list. As an example, while bit is selected, we can only choose between 0x and 1x registers within the Modbus address drop-down list. We can configure the read and write properties of the addresses within this table. However, 3x and 1x registers are read-only by definition. The Modbus address is the address within the server that the map device address will be mapped to. So when a Modbus client, or Codesys in this case, reads this Modbus register, the data that it will read will come from the map device address. While type is set to read/write or write only, an execution function can be configured to prevent unauthorized writes to map device addresses. The table size determines how many bits or words will be mapped within this table, such that if the Modbus address is set to 4x1 and the table size is set to 10, then 4x1 through 4x10 will be mapped to an array or a set of contiguous registers, starting with the address listed in the map device address section. As an example, if the address listed within the mapped device address section was D500 within some external device, then in this example, D500 through D509 will be mapped to 4x1 through 4x10. And lastly, the conversion options will allow you to swap high and low bytes, words, or double words, respectively. With that said, I'll map the word register 4x1 to a variable called rtemp within the Compact Logix. You'll notice that the table size is automatically configured to 2 words. That's because rtemp is a single tag with type real, which is equivalent to 32 bits. If I had defined the map device address as an array, I could modify the table size to my liking. And because it's 2 words in length, we have to consider that this table now maps both 4x1 and 4x2 to rtemp. So the next available 4x register is 4x3. And on that note, if we were to try and configure another table that maps a device register to 4x1, 4x2, or any other previously used register for that matter, a pop-up window will display stating that the desired address overlaps that within another table, and the action of adding that table will be canceled. I'll click OK to add this table to our list, and then we'll add another table. This time, I'm going to map address 4x3 to the first element within an array in the Compact Logix called AData. And although it may be tempting to choose a non-sequential address like 4x10, thus leaving 4x3 through 4x9 unused, defining tables such that they map to contiguous registers will increase the efficiency with which we can configure Modbus mapping in Codesys, while array blocks, which are defined by setting a table size greater than 1, will optimize communication by limiting the number of requests sent by the HMI, all while making the system easier to maintain and upgrade in the future. Within this table, I'll leave the type set to read/write, and configure the table size to 10 words, which, being that AData is an array of dint, should map 4x3 through 4x12 to AData index 0 through AData index 4. Let's walk through the process of adding one more table, and then we'll configure our Codesys project. Within this table, I'm going to map 32 bits within our Modbus RTU device, starting at 0x19 to 0x1 within our Modbus server. The process is nearly the same regardless of which device you choose, and in this case, since we are not limiting the read or write capability, the configuration is quite simple. Now that we've defined our tables, I'll click OK to save this configuration. And now we'll need to add at least one UI component for each device within EasyBuilder Pro. These components will allow the HMI to build and validate device communication. A UI component can take many forms, but I typically recommend using an event alarm to ensure that the HMI pulls from the device regardless of which window is displayed. To add an event alarm, open the event alarm log within the Data/History tab. Click New to add a new alarm, and within the following menu, configure a valid read address. This address can be arbitrary if need be, as it is only used by the HMI to establish communication with each device. I'll repeat this process for each device, and when finished, connect my PC to the HMI's LAN 2 port and download this project to the HMI for testing. Typically, if the HMI cannot read from or write to a connected device, a small pop-up will display with the message "Device No Response." If you see this message, please check the IP address of the HMI, the IP of the device within the project, and the IP configured on that device. Or, when using a serial interface, please check the pinout of the communication cable and the communication parameters. To create our Codesys project, I'll begin by connecting my PC to the HMI's LAN 1 port. This port is assigned to Codesys after Codesys activation, and the IP address of Codesys can be configured within the Codesys tab of the HMI settings menu. Within Codesys, click New Project, and within the New Project pop-up menu, select Standard Project, configure the project name, and define the file location. While the application loads, a pop-up will display asking you to define the Codesys controller, which should be set to Weintek's built-in Codesys or CMT CTRL1, as well as the desired POU language. This setting only affects the first POU. Subsequent POUs can be created with any other supported language at any time. Within the project tree, double-click Device Weintek Built-in Codesys, and click the Scan Network option if available. Once the HMI is found, select it and click OK. Alternatively, you can enter the HMI's LAN 1 IP within the drop-down list under the device icon to connect with the HMI's built-in Codesys. If the device tab displays as shown, select the gateway and click the Add Device button. Within the pop-up, enter the HMI's LAN 1 IP and click OK to locate the HMI's built-in Codesys. Once visible, select the HMI and click Set Active Path. Once connected, right-click Device Weintek Built-in Codesys and select Add Device. Within the following menu, expand Ethernet under Field Buses, ensure that Display All Versions for Experts Only is enabled, and add an instance of the Ethernet adapter with version 3.5.15.0 by clicking the Add Device button in the bottom left corner. With the Add Device menu still open, click on the Ethernet adapter and add an instance of the Modbus TCP master with version 3.5.10.0. Again, you may need to select Display All Versions for Experts Only to access this driver. And once more, with the Add Device menu still open, select the Modbus TCP master and add an instance of the Modbus TCP slave with version 3.5.10.0 as well. With that finished, I'll close this menu and double-click the Ethernet adapter within the device tree to configure the settings such that the correct network interface is selected. To do this, click the ellipses under the interface entry box, and within the network interface menu, select VNet 1, which corresponds with the internal IP of Codesys. Then, click OK. Next, we'll double-click the Modbus TCP master and ensure that Auto Reconnect is selected. And lastly, we'll configure the IP address of the Modbus TCP slave to the HMI's internal IP, 10.255.255.1. And we'll set the unit ID to 1 as well. This corresponds with the station number configured within the Modbus server driver. Before we can map variables to the Modbus server, we'll need to configure the Modbus channels within the Modbus Slave Channel tab of this driver. Essentially, this means that we'll need to reconfigure the Modbus mapping tables within the Codesys project as well. But in this case, we can group instances of mapping tables as long as we've configured sequential or contiguous addressing across the mapping tables defined in EasyBuilder Pro. To add a Modbus channel, select the Add Channel button in the bottom right corner of this tab. To read from our 4X registers, I'll define the access type as read holding registers. Codesys uses a zero-based addressing format, which means that the value configured within the offset, which corresponds with the first address that will be read from or written to, will differ from what is set within the HMI's address mapping tables by 1, such that using an offset of 0, while this access type is defined, will allow us to read from 4x1, whereas an offset of 1 will allow us to read from 4x2, and so on. The difference of 1 between the offset configured and the address in this request holds true for all access types. During this demonstration, I'll configure the length, which corresponds with the number of words that we would like to read or write, to 35, and the offset to 0, meaning that this one channel will allow us to read from tables 1 through 5, as configured within EasyBuilder Pro. And I'd like to note that had we not assigned contiguous addressing within the Modbus mapping tables, it might not have been possible to read these tables with only one Modbus channel. This is because the maximum length of each channel is limited, and in the case of this access type, this limit is 125. So if we had assigned table 1 to 4x1, table 2 to 4x101, table 3 to 4x201, and so on, this channel would have only allowed us to read table 1 and part of table 2, which means that we would have to define additional channels in order to read the remaining tables. Now, to write to our 4x registers, I'll add a new channel with the access type set to write multiple registers. The offset is 0 and the length as 35. I'll also set the trigger to rising edge to prevent Codesys from overwriting data within these registers. To read our 0x registers, I'll configure a channel with the access type set to read coils, the offset is 0, and the length is 45. Lastly, in order to write to a 0x register, which is mapped to an external device, we'll need to configure the channel access type to write single coil and define an appropriate offset. Currently, it is not yet possible to write to multiple 0x registers that are mapped to an external device. This is perhaps the only significant limitation we'll encounter when using this method. Once we've configured each channel, we can map variables within the Modbus TCP slave I/O mapping tab. But we'll need to define some variables within a POU, GVL, or PVL first. Within the POU labeled PLC program, I'll define an array of word for our read channel, and I'll ensure that the length of this array is equivalent to the length of our channel. Now, we'll navigate back to the Modbus TCP slave I/O mapping tab, double-click the variable entry box for the 4x read channel, and click the button labeled with an ellipses. This will open the Input Assistant. Within this menu, I'll select our array variable and click OK. Now, each element within our array holds the value of a 4x register that was mapped to a device. You may notice that the type of this variable also matches the type listed within the type column. This is required unless you expand the contents of this channel and map word variables individually. Let's define a few more variables and a simple program while we complete our mapping. Since the type of our 0x read channel is an array of byte, I've mapped variables within an array of bool to bits within this channel individually. But you can also access a bit within a byte using the method shown. So, if it is more feasible to define an array of bytes instead of mapping Boolean variables to subelements, you may use this method instead. I should also note that while it is not possible to map a real tag to elements within this array, we can easily join elements and convert them to different data types using built-in or user-defined functions. To download this application to the controller, click the gear icon to log into Codesys. A small pop-up will display prompting you to proceed with download. Click Yes or select Login with Download and Update Boot Project if available. Once the download is complete, click the Start button to place the PLC in run mode. Within Codesys, you can see that I am reading an accurate value of rtemp from the Compact Logix. And given this logic, we can change the value of the output bit that is mapped to our Arduino. Thank you for watching this in-depth tutorial in which we've configured a Codesys application within a CMTX series HMI to communicate with a Compact Logix and Modbus RTU device. If you found this tutorial helpful and would like to see more, head on over to our channel to check out the latest technical tutorials. Feel free to check out our forum as well for free demo projects, user manuals, and more. Thank you for watching.